All right, so today we are going to talk about the layers of the Earth. So Earth's interior, when we talk interior, we're where? Interior, inside, okay. Okay, so Earth's interior consists of three major zones. So it is defined by its chemical composition, each specific zone. So we've got the crust, the mantle, and the core. Okay, so the crust is where we live. This is made up of solid rock. Okay, it's the thin, rocky outer layer. It's divided into two types, continental and oceanic. And we've seen these terms before. Okay, so continental, think what? Over what? Or on what? Land, right? And oceanic is going to deal with ocean, water, right? Okay, so continental is anywhere from 8 to 75 kilometers thick. Okay, the average is about 40. So that is very, very thick. And that's what I need you to take away from this. Okay, it consists mostly of granitic rocks. We've seen this term a lot throughout these different lessons. Okay, next is the oceanic. This is roughly 7 kilometers thick. So this is very thin. So you need to know that the continental type is thick and the oceanic is thin. Okay, so this consists mostly of basalt and gabbro. So here is a picture just to give you an idea. You've got continental on the left, dealing land, and oceanic to the right, and that is dealing with our water. All right, let's go through some questions. So the Earth's crust can be categorized two ways, oceanic and continental. True or false? True, very true. Continental crust is thinner than oceanic. Okay? So what is it then? The oceanic is thinner. The crust is the thick, rocky, innermost layer of the Earth. True or false? True. True or false? True. That's true. That last one? Are we sure?
Oh, you say innermost.
So is it true or false? It's false. One word can make a statement false. So what's the correct answer to make it true? The outermost layer, right? Outermost layer. So the crust, think you're eating a piece of pizza. What's the outer part of the pizza pie? The crust, okay? All right, now we're going to talk about the mantle. So the mantle is 82% of Earth's volume. Okay, that takes up a big chunk, 82%. So this is solid rocky shell that sometimes acts like a liquid. Okay, so it's kind of plastic-like and it will flow. So this extends to a depth of 2,890 kilometers. Okay, we don't need to be too concerned with these numbers, but we need to know when I'm talking things are thick versus thin. Okay, this is the dominant rock in the upper mantle is peridotite, and it is composed mostly of silicon and oxygen. So this is how a mantle moves. It moves much like a lava lamp. Anybody familiar with a lava lamp? Okay, so this is called convection. So what essentially is happening, those globs that get warmed by the light, okay, that's in the lava lamp, they are going to rise to the top, and then the ones that are cool are going to sink to the bottom. Okay, so the warm ones are going to rise and they're going to get warm from the light, and the cool ones will sink. Okay, so remember we said what kind of air rises? Warm air, hot air, okay, and cold air sinks. Okay, so much like this. All right, true or false? The mantle is made up of a material that can act like a solid and a liquid. It's true. Okay. Next, the mantle is the smallest or thinnest layer of the earth. That's false. Okay, we said that it makes up a big portion. Okay. All right, next is the core. Okay, so this is a sphere composed of an iron nickel alloy. It is similar in composition to a metallic meteorite, and the temperature here ranges from 5,000 to 7,000 degrees Celsius. Okay, so here's a picture of what I'm talking about, and we're going to get into a little more depth here with the core, because as you can see, there's two parts of the core, inner and outer. Okay, then you can see your mantle, and then outside of the mantle would be the crust. Okay, so we're going to talk about some layers, and you're going to see an assignment on this once we finish for the day. Okay, so the first of these is the lithosphere. Okay, this is the crust and upper portion of the mantle, the solid part. Okay, so this is about 100 kilometers thick. Then we're going to move down to the asthenosphere. This is also part of the upper mantle. Okay, temperature and pressure cause the rocks to easily deform, very much like hot wax or silly putty. And then moving down, we have the lower mantle. Okay, this is from about 660 kilometers down to the base of the mantle. This is a very rigid layer. Okay, so rocks are still hot and they can still flow gradually. Okay, so lithosphere, asthenosphere, lower mantle. All right, now we're going to break down the core. So we've got the outer core and the inner core. So the outer core is the liquid layer. That's about 2,260 kilometers thick. So this layer is thought to generate the Earth's magnetic field. Okay. Then we've got the inner core, and this is a sphere with about a radius of 1,220 kilometers. So despite the high temperature, because we've seen the temperature of the core, okay, this area is solid because of the intense pressure that happens here. Okay. So breaking up the layers, you can see them better in this picture. Okay, so you've got your mantle, the different parts of the mantle, and then you move down, you see your outer core and inner core, and then on the very top, the outside would be your crust. All right, true or false? The lithosphere is composed of the crust and the upper solid portion of the mantle. The lithosphere? What's the lithosphere? True. The core is composed of two parts, true or false? That's true. What are they? Inner and outer, right. Okay. The inner core is liquid and the outer core is solid. True or false?
False.
What is it? Very good. The inner core is solid and the outer is liquid. Nice job, y'all. All right, so moving on, temperature and pressure increase. Temperature and pressure increase as you go further down the layers. So as we move down the layers, we listening? Temperature and pressure increase. Okay, so if we can't actually see inside, then how do scientists know? And this is what we're going to talk about. So here's another picture. This shows you the different temperatures. Okay, so outside you've got your crust, you have your mantle, and then your inner and outer core. So how do we know? And this is via seismic waves. Okay, so these are vibrations that travel through the earth. These are caused by earthquakes, and we're going to get into earthquakes more next week. There are two main types, P waves and S waves, but the S waves will not pass through the liquid. Okay, so there is an area between the crust and mantle where the velocity of seismic waves increase very abruptly. Okay, so out of nowhere. So some interesting facts. Density, mass divided by volume. Okay, so the density of Earth is 5.5 grams per cubic centimeter. So neither the sun's heat nor winter cold penetrates the Earth below 20 meters. At 20 meters and above, the temperature is relatively the same as the surface temperature, except where there are volcanoes and hot springs. We will also talk about volcanoes more next week. And then below that 20 meters, the temperature will increase 1 degree every 40 meters. And we've seen and talked numbers and how thick. So as we go down, the temperature is very much going to increase. All right, true or false? Temperature and pressure decrease as you go farther down into the layers of the earth. What is it? Increase, right? That's why I stressed that one. Seismic waves are vibrations that travel through the earth and are caused by earthquakes. Very true. Okay, and like I said, we will talk more about this next week.